All right. Let's see where to start. I've taken a look at the exam 3 performances. As I predicted, generally they tracked with the grades on exam 1, which meant the people who did well on exam 1 did well on exam 3. People who did poorly on exam 1, with a few exceptions, tended to do poorly on exam 3. And your performance on exam 2 was irrelevant to your performance on exam 3. But on the whole, I thought that they still were better on the whole than exam 1, thanks to the outliers who improved and clearly worked hard to improve. So thank you for that. So here we are in the home stretch. We've got about 2 weeks of classes left. So what we're going to do is we are going to push forward and use the propositional logic tools that we've learned, and we're going to do what I think of as some pretty cool stuff with them. Today we're going to cover extended inferences, and then we are going to cut. And extended inferences are where you do the S&I rules with very big, complex statements. And then we might start bridging into multiple step proofs. And then the remainder will be doing very complicated proofs as we go on. Don't forget your S&I rules. We're going to need them. We're going to use them a lot. You need to apply yourself to this because some of this, again, it's like calculus. It's going to use what you learned, except it's going to get harder. That's the simple, honest truth. All right, let's get us a session number here. This will be session number 701-856. And maybe I need a darker marker than that. There we go. All right. So this is roughly 6.13. So here's the basic principle of extended inferences. Any rule that I've taught you, S or I rule, they can be used with statements of any complexity. The one key rule that you absolutely have to remember is that a statement is defined by its outermost operator and presence or lack of presence of a negation outside the outermost parentheses. So if you have something that looks like this, both if A then B and either C or D, this is only an and statement, and only the and can be used. Only the S rules for and can be used. Why? Because that is the operator that is in the outermost parentheses. These other two operators are within double parentheses, and you cannot cross into a second set of parentheses to use the operator. So both if A then B and either C or D, you can use an and statement, and you can infer out both halves of the and statement. If that and statement is true, then you can infer out if A then B, and you can also infer out either C or D. But you can't try to use that arrow rule, and you can't try to use that or rule from this statement. Now, once you've done the and statement and you have these two separate truth statements, then you can try to use one of these. And that's what we'll be doing in more complex proofs, we'll be doing multiple step inferences. In the same way, if I give you this, it is not the case, or rather, neither if A, then B, nor either C or D. The only operator you can use is this or that's only within one parenthesis. And since we have a negation outside the outermost parenthesis, you can only use the rules for negated or, which means you can infer out the opposite of both sides. It is not the case of if A, then B, and also it is not the case of either C or D. All right, let me pause. Questions, thoughts? This is probably the most important rule for the last 2 weeks of the class. Because there's going to be lots of times you're going to have these longer statements with multiple operators. And if you try to cross that second set of parentheses, you will immediately mess up your proof. And this is why it's so important that you have the S and I rules down cold in general at this point, because you're going to need to use them with more complex things, and you're going to need to use them in multiple combinations, multiple steps. So if you're still struggling with what do I do with the negated arrow again, then, you know, if you have to do five-step proof, pretty good chance if you're getting them right only 80% of the time, well, then you're going to mess up your proof almost every time. And you don't want that. All right, let's look at the PowerPoint I put up there. So here, remember, so let's take something super simple, the AND rule. The AND rule says, if I give you A and B are true, the truth of A and B, well, any AND statement of any complexity, I can still use that AND rule. So bullet point 3 here, within 4 parentheses, is something like both, if A, then B, if and only if either not C or D, and if not E, then F. Well, then first thing I have to do is figure out what is the outermost parenthesis. But you'll see it's that and there's no negation, so I can just use the and rule. And whatever's on the left of the and will be true, and whatever's on the right of the and will be true. The exact match, without adding or removing any negations. And all 6 of the rules, actually 7 of the rules that we've taught you so far will work like that. Same thing with something, frankly, a little more complicated, like the false if then. From negated if P then Q, in general, you can get the match of what's on the left of the arrow, the P, and the opposite of what's on the right of the arrow, which would give you a not Q. In the same way, any negated arrow statement will get you the match of what's on the left of the arrow and the opposite of what's on the right side of the arrow. So, from bullet point 2, it is not the case of if both P and either T or not S, then either Q or N and not W. In the same way, once you figure out what the outermost operator is that arrow, because that is the one that's only within one set of parentheses. And then you check outside the outermost parentheses, and it turns out that it's a negated arrow statement. You use NIF, negated if then, in the same way, which allows you to infer out the match of the left, both P and either T or not S, and the opposite of what's on the right of the arrow. That is not the case of both Q or N and not W. And all seven of the S and I rules work that way. So here, let's give you just a little practice and see if you get it. What, if anything, may we derive from this statement? It is false that if both A and B, then not C. Okay, good. That's very promising. Of the people with clickers, of the 11 people with clickers, it looked like 10 out of the 11 got it right. You can get the exact match of what's on the left side. This is a negated arrow because the arrow is in the outermost parenthesis. You get the exact match of what's on the left of the arrow, the A and B, and the opposite of what's on the right of the arrow, the not C turns into a C. Very good. All right, let's do another one. This time, let's make it a little harder. Let's use an I rule. So what, if anything, can you get from if both A and B, then not C, and the additional premise, not both A and B? All right, the correct answer is nothing, because to use this arrow, you need the exact match of what's on the left side of the arrow or the opposite of what's on the right side of the arrow. And the exact match of what's on the left side of the arrow is the both A and B. But this is not the exact match because it's negated. Therefore, you can get nothing from the combination of these two statements. And most of you got that. A comfortingly high number of you got that. How about this one? All right, so here's what you have to see. The outermost operator is an and we have a negation outside the outermost parenthesis. Therefore, we can't use the and rule. We have to use the I rule for negated and. And to use the I rule for negated and, you need an additional statement that matches one of the two sides. Since we don't have a second statement at all, you can get nothing from this negated and statement, as the 77% realize. So you would either need a either G or H, or you would need an either I or J, and then you could infer out the opposite of the remaining side. But we don't have that, so you get nothing. All right, what about this? Both A and B, or either both A and B, or if C, then D, and the additional claim C. What, if anything, can you get from this? Good. The correct answer is nothing. Why can't I get D? Right. So because that's an or statement, but there's something even simpler than that. A simpler rule that I gave you than that. Why can't I get a D? Okay. Why can't I get a D? It's not the outermost operator. The only rule you're allowed to use is that or. Now, if there is a way for you to get that if C then D out of this larger statement, then you could use the C with the if C then D. But you are absolutely not allowed to reach within that double parenthesis to use that if C then D. Crossing a second parenthesis is not okay. It's like working with electricity. You're allowed to touch one wire, but if you touch the second one, that could be really bad news. Actually, don't take my advice about electricity. Don't touch any wires. Talk to somebody who knows what they're doing. All right. Questions? Because I've just taught you a key rule for the rest of the course. And again, if you know how to use it, great. But if you only have it 80% down, it's going to cause problems. All right, let me see if I can find my PowerPoint with no, that's not it. All right, here we go. So as we get into chapter 7, what we're going to be doing is what are called proofs and refutations. Proofs will be when I give you a set of premises and a conclusion, and I want you to prove that from that set of parentheses, you can reach that conclusion. So what we've given you is the tools, but we've only given you tools and told you to apply it to one step. And for our final act, for our grand finale, you will be using the tools in complicated combinations to do multiple step proofs. So here's a sample multiple step proof. I've given you 3 premises here from if H then not B, and a second premise, if D then B, and a third premise, H. We want to prove the reality of not D. And we're going to need to use more than one step. For those playing along at home. From these three premises, I will attempt to prove the reality of not D. So what we have to do is we have to look at our three premises and ask, are there any S rules I can use on any of the statements? And in this case, the answer is no. Then I have to look a second time and ask, are there any I rules I can use with any combination of the three statements? And specifically looking, is there anything that will get me closer to a not D? So I look here and I say, well, look, this first premise says if H, then not B. And this third premise says I have an H. So the combination of if I have an H, then I can get a not B. And the third premise saying I have an H, I can infer step 4, not B. And when you do use an S or I rule, you have to cite it. You say it's from 1, the combination of 1 and 3, using the arrow rule. Everyone see what I did there? All right, but guess what? I'm trying to prove not B, not D. So am I done? No, I haven't gotten a not D. So then I have to do it again, and I have to start all over. I have to look through everything systematically and say, do I have anything I can use an S rule with? Answer still no. Do I have anything now that I can use an I rule with, especially taking into account that I now have something new to use, the not B? And what I look at is statement 2 says, if D, then B. 4 says not B. And if I remember, I have 2 arrow rules. One that says I can get an inference if I can match the left. But there's a second one that says I can do an inference if I can get the opposite of what's on the right of the arrow. So because I have if D, then B, and I have not B in statement 4, I can therefore get not D, which is from 2 and 4. And again, it uses a different arrow rule. If I want to be really technical, the first one uses the modus ponens arrow rule, and the second one uses the modus tollens arrow rule. But I won't be that much of a stickler, as long as you know you use the arrow. So, ta-da! For my next turn, I will make the Statue of Liberty disappear. I will steal the Declaration of Independence. All right, thoughts, questions? Am I making this too easy? All right. Y'all, yes.
When you're doing out the 4 and 5, next steps,
Yes.
when you say from 1 and 3 or 2 and 4, is that coming from the first premise and the third premise, right?
Right. So yeah, these numbers down here refer to the statement numbers that I used to get the inference. And by the way, although nobody has asked, you can use a statement more than once. And it is possible to have statements that don't get used. So we are going to start reaching the point very soon where there will be more than one right way to do a proof. Because, especially the more complicated ones, there's sort of different paths you could take to still get to the same final conclusion. So you'll get to the point where there's 4 or 5 right ways to do a proof, but there will still be. So, and frankly, this is what, grown-up life is like. There's more than one right way to do it, but there's still an awful lot of wrong ways to do it. Yes?
So should we always look for S rules first?
Yeah, in general, I recommend looking for S rules first, and here's why. Systematically, you're going to want to break out anything you can from a complex statement using an S rule, and it will give you more lines to work with, and looking to use a combination of statements for an I rule. So if you look for the I rule first, often the thing that you need to make the I rule work won't be there yet, because you have to use the S rule to break it out in order to use the I rule. So here, let me see if I can think of an example off the top of my head of that. So let's say, because you've asked a good question. It's not arbitrary that I suggest the S rules first and then the I rule first. All right, so let's say statement 1 is if A, then B, and statement 2 is both A and C. So if we try to just do the I rule first, I would look at each of these and I'd say, nope, can't do an I rule. So I guess I can't use an I rule with number 1. Then with number 2, I'd say, okay, let's try the S rules. Number 2 will give me statements 3 and 4. I can get A and I can get C. But then if I would have to remember to go back yet again and try the I rule again. So there will be, so just sort of logically, using the S rule first will more often get you the component that you need. Whereas if you start with the I rule, you might risk not going back and trying the I rule again. Although if you wanted to do the I rule first, I guess you could, as long as you kept going back every time you found a new line to use. And let's say this was a proof, I was trying to prove B from this, then I would use, so let's see this, so these are what's given. 3 and 4 are both from the AND rule on 2. And let's say I want to prove B, I would use 1 and 3 with the arrow rule. Modus ponens, for those of us keeping score. And note, in this case, we have a line that we never used. We never used 4. But you should still get both halves of that AND out when you do the AND, even if you're not sure you're going to use both. Just by matter of habit, it's good to, it's kind of a best practice. Because it's better to sort of bust it out and then not need it. Now, of course, with something this simple, if you're doing well in the class, you can probably see that you're not going to need it. But sometimes it won't be that obvious, but you will. So is it okay that we did, we inferred out this C and didn't use it? Absolutely. All right, let's see how you're all doing. I want you to do this one yourselves. So I'll give you a couple minutes. I want you to find J, prove J from the following claims. If F, then if G, then H. If not F, then J. And it is not the case of if G, then H. From that, prove J. All right, who's got it? Who needs a couple more minutes? About a minute or two. Who's utterly lost? Oh. All right, well, here is what you can do. As I've been encouraging you, use S rules first. And if you did, you looked at number 3 and got G and not H from number 3, from the negated arrow rule, sometimes called NIF. Then we looked at all these and asked, is there an I rule we could do? And it turns out there is an I rule, but you've got to use the extended inference. And you have to look at 1 and 3 and say, look, if I can match the left side of the arrow in 1, the F, or if I can get the opposite of everything on the right side of the arrow, the if G then H, then I can do an inference. And 3 is the exact opposite of the right side of that arrow. So that would get us step 6, which would be a not F from 1 and 3 from an arrow rule. And then once we've got 6, we start looking again and ask, is there any S or I rule we can use? And if we spot the combination of 2 and 6, 2 says I need a not F to get a J. 6 gives us not F. So step 7 will be J from 2 and 6 using the left to right arrow rule. How many of you got something like that? Good. Those who are actually here, I think are doing pretty well. Yes, sir.
Is it all right, like 4 and 5, because you kind of find that?
Yeah, if you were insightful enough to realize that you don't need that, you didn't use it, yeah, that's all right. I mean, again, in the more complex ones, it's probably better to crack those out anyway, because you might need that, like 5 steps later. And if you haven't done it early on, you might forget. But you're right. It's not. It is. There's more than one right way to have done this one. And as you are becoming, adults in the logical sense, sort of getting a bit of a mastery of logic, you can make the grown-up decision not to do the extra steps. So yes, so step 1 is to get a not F. And so here was what you did the simpler way. Very good. All right, now here, so far we've been doing pretty simple ones. They both were solvable in 2 steps. Sometimes though, it's hard to see sort of straightforwardly how to get to the conclusion. So I want to teach you a strategy I call the backward strategy. And instead of just doing the inferences that I can see to do from the statements that are given, instead, I encourage people to learn how to work backwards. So you start by looking for what you're supposed to prove. So here, I've given you 4 statements. We're trying to prove S. So here we want to ask ourselves, what's going to be my next to last step at the end? To get the S at the very end, we're going to need an F. So I can look and see that my next to last step is going to be to use an F to get an S. So I'm going to see towards the end, I'm going to use statement 4. But I'm going to need an F from somewhere to use statement 4 to get the S. So then again, I work backwards again, and I say, well, gee, I'm going to need an F, and I'm going to get that F from statement 1. Somehow I'm going to need a not A to plug into statement 1 and to get out that F, to use that F of statement 4 and get the S. All right, but still, then I have to ask again. To get that F out, I'm going to need a not A. So I'm going to look at statement 1, and I'm going to need a not A. So then again, I'm going to ask, well, gee, where in the world am I going to get a not A from to use with statement 1? And the answer will be, I'm going to have to do something a little weird with statement 2 that turns this A on the left side to a not A. So to get the not A that I need, I'm going to have to use statement 2 with statement 3. 3 will deny the opposite of the right side of the arrow and get me the opposite of the left side of the arrow. So as these things get more complicated, instead of just sort of blindly doing whatever inference you can, as we have in our first 2 examples, it's increasingly going to be strategic to kind of work backwards in our heads as much as we can. Maybe write yourself a strategy note for what you're going to try to do. So then, when you, based on the strategy that we've suggested, the right way to do this proof, or the best way to do this proof, is to start with the combination of 2 and 3, if A then not D, I'm sorry, if A then D, and not D, using the modus tollens arrow rule that gets us not A. Once we've got not A, we can plug that in to statement 1. Combination of 1 and 5 will get us F. And once we've got that F, we can plug that into statement 4, if F then S, and that will get us our conclusion to be proven. So again, this is going to get more complicated and more steps. And the more steps that are involved, usually the better off you are looking at where you want to end up and basically working backwards. All right, one more. Why don't you all try to solve this one? From neither S nor R, and a second premise, if B, then either S or R, and a third premise, either not Q or B, try to get not Q. Yes. Yeah, that's a good question. Normally, I have a blue book section. I've got to figure out what to do for that. Maybe I just provide like an essay, a short answer essay box, and not multiple choice. Which of course is more work for you and more work for me. Such is life. But I'll talk to the powers that be, see if we're at a point where we can do blue books again. All right, well, let's do this one quickly and then I'll let you go. Now, I'll point out a common mistake I see people make is they start using the conclusion as a premise. Now, don't do that. I mean, so just, so far I've tried to keep it very clearly separate, but often the way the book presents it, it just kind of lumps it in. It just doesn't have a number next to it. So this one, from 1 and 2, you can use this if B, then either S or R, and the negation of S or R. That will get you a not B. From 1 and 2, the MT error rule. And then once you have that, you can use 3 and 4 to get not Q, because 3 is an or statement that says either not Q or B, and the negation of B, which that's 3 and 4 or rule. So that's the easiest way to do it. Now, if you did everything I told you to do, you might also have inferred out not S and not R, but that's kind of optional. All right, so for next time, read the horrible section 7.1, and we're going to do bigger proofs, that are more complicated than this, using a new tool that the book's going to introduce. So, very good. Thank you for your hard work. And if you have friends that are not showing up in class, encourage them to watch the video and watch it closely. As the people who aren't physically in the room, that correlates with not doing great in the class. So encourage them to be here physically or at least watch the video. Thank you. I mean, I'm not going to worry about it. So just send me a reminder. You need to use the whole thing set. Is that what you're saying?
I don't know, so I was just trying to look and feel like I was doing that, and then
Why, well, no, it doesn't run that.
oh, it doesn't.
Why don't you try changing it out to the and see if
That's not my account, and it doesn't want me to my password.
do you have a hotspot on your phone?
Quick question.
Yes.
To do exercise A before 7.1?
I think so. Well, follow the principle I gave you earlier in the semester. Spend an hour on it.
Okay.
So, as long as you're mastering the principle, you don't have to obsess over the completion of every last one. But if you're not getting it, you need to get it.
Yeah. When I was doing, when I basically finished exercise last night, I was a little confused. I was like a little hesitant. But
Sure.
Now in class, I'm a little better. I like the way here, the way the textbook actually did it was like assuming the opposite.
Well, and we're gonna have to use that assume the opposite rule next.
But, it's always been my harshest criticism of the textbook. I mean, to teach people to start assuming, doing the reductio proofs, which is what the opposite is. To teach people to do that without teaching them 2 and 3 step regular proofs, that's just, you're not doing people any favors.
Yeah.
But the assume the opposite strategy lets you prove things that you can't prove. So this is, yeah, I put training wheels on this lecture.
I think that's a little bit more helpful. for
Yeah.
me.
Good.
Bigger picture.
That's the goal,
Because the reductive, that's the
yeah. Yeah, the R stands for that.
gotcha.
But yeah, so yeah, go back, spend an hour on it again, and hopefully it'll work a little easier. And if you're still having trouble, I mean, I still haven't really lectured on it. So you'll have another lecture to ask questions and try to figure it out to you.
Perfect, sounds good.
Excellent, thank you.
Have a good weekend.
So how's it going? Okay, well, don't worry about the time. Send me an email when you're done and just say, hey, we talked after class, like you said, it hung for 10 minutes. Say, give me an extra. I'll give you an extra 10 minutes. I intentionally said it not to force you to end. But yes, you can give yourself an extra 10